In this example, we're going to solve this linear system by substitution. So the first step that we're going to take is to identify one of these variables, which will be easy to solve for. So the coefficient is 1 or -1. And it looks like this y right here has a coefficient of -1, so he'll be easy to solve for. So this 4x minus y equals 7. So in order to make this y positive, I'm going to dump him over to the other side by adding y to both sides. But in doing so, I need to subtract 7 to kind of get rid of that constant and bounce him back over to the other side. So y is by itself on the right, and we have 4x minus 7 that's going to be on the other side. So I know that the expression 4x minus 7 is equivalent to y. So I'm going to take that 4x minus 7 and I'm going to substitute it in for y, but in the other equation. So the second equation is the one we use to solve for y. So the first equation is the one that we're going to substitute into. So that's 2y minus 8x equals 5. So 2 times y, but our y is this expression, 4x minus 7. Okay, so I'm going to go ahead now, distribute, and solve this equation. 8x minus 14 minus 8x equals 5. So you'll notice an 8x and a negative 8x, these are actually going to cancel each other out, and I'm left with negative 14 equals 5. So here was an equation where all the variables canceled, and I was left with a statement. In fact, this statement is a false statement, so that means that this equation has no solution, which means that the system as a whole has no solution. So if I was to graph these two lines, they would come out to be parallel, so there are no ordered pairs that are solutions of both equations simultaneously. So this linear system has no solution.